All right, recording's going. You guys do a good job on the slab. Okay, so see how you guys are doing here. You guys came up with this free body diagram. Weight down, buoyant force up. Buoyant force is rho VG, right? Density of the fluid, volume displaced, gravity field. Weight is mg. Density of water, 1 gram per cubic centimeter or 1,000 kilogram per cubic meter. Gravity field is 9.8 meters per second squared or 980 centimeters per second squared. One thing you got to keep track of is units. Like there's some centimeters here, there's some meters. You guys got to be careful. Okay. What do you guys come up with for y in terms of x? Like as you fold up x more and more and more, y gets smaller, right? Okay. But we got some table values right here. We got some table values. You guys said if you didn't fold up x at all, then y would be the full 12. If you fold up 1 centimeter on each side, y goes down to 10. Okay. You guys see every centimeter you fold, y loses 2 centimeters. You guys are folding on each side. Okay. Then you can write an equation. Guys, what equation did you guys come up with? What's y in terms of x? Y is equal to negative 2x plus 12, right? Right. And that exactly matches these table values too. Right? Because here, watch it. How about this row right here? If x is equal to 2, so negative 2 times 2, that'd be negative 4, plus 12 is 8. Hey, look, that actually aligns with what you guys did. Right. How about volume? Did you guys do y times x? Because base, width, height, multiply. Okay. Now, this one. Here's y in terms of x. Here's volume is y squared x. Can you guys substitute out this y right here in terms of, well, y is equal to negative 2x plus 12? Right. I bet that would look kind of like this. Volume is equal to, okay, well, here, I'll just start with that. Y squared x. Is that true? Okay. But in place of y, I can substitute negative 2x plus 12. Right, now it's all being squared and then times x here, right? Right. Ooh, guys, what algebra term am I thinking? 4 letters. What to multiply the square right here? We want to square this term. F-O-I-L. You guys remember FOIL? F-O-I-L from algebra? Okay. Try this out. Guys, what's negative 2x being squared? What is that? 4x squared? Okay. What's negative 2x and 12? What's that multiplied together? Negative 24x. So then you have to do that for outside and inside. So that all together, that's negative 48x. What's 12 squared? 144? Right. Now, I still haven't multiplied this x here. Guys, can you distribute that x into each of those 3 terms on the inside? Right. You guys see that? Here. Volume in terms of x equals. Okay. Is that the equation you guys got for this right here? Right. That's the volume of any boat, this boat and this boat, and any boat you made, in terms of how much did you fold up a side. That's exactly what that equation says. Guys, yeah? Okay. Now, if x is in centimeters, that would be in cubic centimeters. All right. So you guys good? Okay. Now, how much weight can this hold if I start stacking weights in these boxes? Okay. Now, here's where you could get this empirically. You could just stack weights and count it. Okay. Or you could calculate it because the weight can go up to the buoyant force. If this boat sinks all the way down, like just up to the brim, right? It's like, don't breathe on it because you just barely breathe. Isn't that this formula right here, rho VG? Now let's do base SI units here so we can get the force in newtons. See how the force is in newtons? Right? Guys, what's density in base SI units? We have 1,000 kilogram per cubic meter, density of water. Right? Gravity field could be 9.8 meters per second squared. Now, guys, here's where it gets tricky. You guys see this volume right here that's in cubic centimeters? I don't want cubic centimeters. I want cubic meters. How do you convert that? That's this right here, isn't it? So divide by 100, 100, 100, which comes out to a factor of 1,000,000. Okay? Right? You guys, factor of 1,000,000? Okay. So let's see if this makes sense. Suppose you did the calculation here and you got how much force it can hold in newtons, right? You guys see that? Right. And let's say all of you look at the same boat and you got 3 friends in a group. And one friend says, I think the force it can hold is equal to 0.001 newtons. And someone said, well, that didn't make any sense. I got 1 Newton. And someone else says, oh, I got 1,000 newtons. Right? Right. And they say, well, those are completely different orders of magnitude. Which one of these makes the most sense? What can the boat in your tank hold? Which one of those numbers? Yeah, probably about 1 Newton. It's probably pretty close. Actually, I got this calculation here. Right. just make sure you guys are getting the correct order magnitude. If you did the correct rho VG, the correct units, you guys do this little conversion here, convert cubic centimeters to cubic meters. You guys got all that? Right, you guys good? We're good? Right. All right. Oh, and I wonder what's the maximum weight you can hold. Now I did one row here, I got almost 1 Newton. That's about 1 Newton right there, right? Do you guys think that any of these boats could possibly hold more than a Newton? And if so, how much more? Right. What's the biggest weight you guys got to hold? Right. Right. Now on the back, I think I helped you guys out a little bit on these graphs. So if you didn't fold one side at all, so we're back to the flat square, y was equal to how much again? If x is 0, y is equal to 12. That point right there. If you fold x all the way to, how much can you fold x before it makes this shape? 6 centimeters. And now y is equal to what? 0. So 6, 0. Right. And guys, what shaped graph connects those 2 points? In fact, you know what? You already have the equation for this graph. Guys, this graph, y versus x. Do you have an equation, y versus x? Yes, I see. I see right there. Right. Does that equation describe whatever graph's supposed to go here? It could fit through those 2 points. I think the more you fold up x, the less y gets. Right. Now the tricky graph, guys, this very last one. Tricky graph is how much weight can you hold? By the way, the shape of this last graph is the same shape as volume versus x, but it says buoyant force versus x or carrying capacity versus x, F max versus x. Right. So as you go from this flat shape where you don't fold at all, guys, how much weight can this hold again? 0. That's that point right there. And the most you can fold x would be 6 centimeters, but that just goes back to flat shape. That's also 0. Right. How about these boats in the middle? Like this boat, this boat. Guys, some kind of upside down type curve, right? In fact, it'd be the same shape as, well, where's my equation? It'd be the same shape as this equation right here. You guys see this cubic right here? It's something like x cubed, something, right? Right. Oh, here, I'm going to draw a general shape. I don't know if this is exactly what it's going to look like, but I can draw it. It's generally going to look something kind of like this. Okay. Now, you guys know x cannot go more than 6, but mathematically in the equation, it would bend up, something like that, right? And I did draw all that because there's one last detail I want to point out to you guys. Do you guys catch this detail in italics right here? It says, calculus students, use calculus to optimize the dimension of the boat box, which is really what I want everybody to do, just maybe more empirically. Okay? So how could you figure this out with calculus? Here, guys, show hands. How many say who's in calculus right now? Who's taking calculus? Okay, here. Let me tell you guys some calculus right here. So calculus is about instantaneous rates of change. And on a graph that shows up as a slope. Can you guys hold a ruler flush to this curve? Right. And as you go from left to right, what's happening to the slope? The slope's getting what? Yeah, it's decreasing. It's getting shallower. And, ooh, guys, if you're at the top of a hill, what's the slope at the top of a hill? 0. For that matter, what's the slope at the bottom of a valley? Also 0, right? Okay. Now, there's a calculus process where you can take a rate change in this equation. If you're in calculus, you know what I'm talking about. Right? And that'll tell you something about the slopes. So if you ever want to maximize, or for that matter, minimize an equation, you set the slope equal to 0. And then you can solve for x. Now it's a process here. I'm not going to quite do it here, but if you're in calculus, you'll be able to do that. It's called the derivative. Set the derivative equals 0. You can solve for x, and it will spit out exactly the correct answer to this question. Okay? And I'm telling you, I'll tell you one answer that is not correct, is 3. Right? So 3 is not the correct answer. Right? So x, if you fold x up 3, that does not optimize the boat, but something else does. Right? There's some value here that's going to optimize, like some optimal value x. You can fold up the side of the boat to create the largest volume and therefore carry the most weight. Okay. If you guys have all these details, you guys have the equations, you guys have at least a few rows on this table, and you guys have the 2 graphs completed, you can turn that into the grade tray. And if you didn't quite finish the graphs, then you can turn that in tomorrow.